All right, this is APBC Calculus. We're doing midterm review, and this is multiple choice question number 4, which is a non-calculator question. So we are asked to integrate from 0 to 3 of dx over 1 minus x squared. So this is an improper integral, because here's the problem. This thing has a vertical asymptote at x equals 1, right? Because when 1 minus x is 0, we would have a vertical asymptote. So this is improper, right? So basically what's happening here is we're going to have to split it into two separate integrals. We're going to have to say that this is the integral from 0 to, and then we don't want it to be 1, right? We're going to say b. We're going to say the limit as b approaches 1. So if you're between 0 and 1 and you're approaching 1 from the left, right, of this thing. Now, how much of this work you actually show on multiple choice is a little bit up to you, because realistically, it's multiple choice. So of A, 2, 3. So nobody's going to see this work. I mean, I'll see the work just to see that you did the work, but I'm not going to grade it, and the same thing is true on the AP. So this is the logic of what's happening, right? Now, it is worth noting that I would probably cheat, and I would probably just do the work on the integral off to the side without the bounds, because this is a pretty simple u sub integral, right? So it's kind of worth saying, oh, hey, u is 1 minus x, so my du is negative dx. So this is the integral of negative du over a u squared, or the integral of a, I need a little bit more room here, this is the integral of a negative u to the negative second du. So I'm going to raise the power by 1, which would be a negative 1, and divide by the new power. So I'm pretty sure that I get that this is a u to the negative 1, or a 1 over u, right? So 1 over u. So the reason it's worth doing that work sort of off to the side here, right, is because I don't need to do this integral twice, right? It's much, much easier to just find this integral once and then deal with the b's and a's as needed. So the limit as 1 approaches, or as b approaches 1 from the left of this thing, right? So this would be a 1 over 1 minus x from 0 to b. So right away, I'm going to go ahead and tell you that this is answer E. This is divergent. And I'll tell you how I got there in just a second. So here's the issue. So this is from A to 3. The second you end up with an answer that has essentially an infinite value in it when you plug in, like if these don't all conveniently disappear, this thing's going to end up being divergent. So if you look, this is still a vertical asymptote, right? It's still an issue. Like if I plug 1 in, I'm still going to have 1 over 0. That's a problem, and this is divergent. For these improper integrals, if they're going to converge to a value, then when you get to this stage of the game and you're substituting in, you're getting all reasonable numbers. Like if you're plugging in infinity, and you might get a 1 over an infinity, because 1 over an infinitely large value is 0. But you're definitely not getting these ugly numbers. You're not getting zeros in the denominators. And the same thing would happen here. If I plug this in, it would still be a vertical asymptote. Now, the problem is if you didn't pay attention to this being improper and you just tried to integrate, you're going to get a number, and that number's wrong. And the reason you're going to get a number is because essentially you're going to get a 1 over 0 here, and you're going to get minus a 1 over 0 here. And if you treat them like they are regular numbers, you're going to feel like, ooh, they disappear, they subtract, they're gone. But that's not how 1 over 0 works. It is not a number. It doesn't act that way. So this answer is divergent.